So let's take a look at some nuclear decay problems. In this case right here, you have to know the type of radioactive particles that are emitted. So you have to memorize this. This is alpha, which is 4,2 helium. Couple of things. Remember that top number is the mass number. That bottom number is the atomic number of protons. A beta particle is just an electron, so 0, -1. Positron, again, this is for PET scans, 0, +1 is a positive electron. And then gamma rays are the smallest and the most penetrated at 0, 0. It really doesn't have any mass, doesn't have any charge associated with it. So this is something you're just going to have to learn. The 4 types of radioactive particles. Again, when it says nuclear equations, we're changing stuff in the nucleus. We're changing the number of protons, neutrons, whatever the case may be. So in this case right here, say we have uranium. Again, we go by its mass number. Uranium-238 emits an alpha particle. So to complete this equation, we have uranium-238. And again, 90 is the atomic number. Again, you get that from the periodic table. An alpha particle. So the alpha particle is going to be 4,2 helium. So again, we have to know that. It's 4,2 helium. And then we're trying to figure out, they say, well, what other element is being formed? So again, with nuclear decays, nuclear reactions, we're changing the number of protons, neutrons, we start forming a new compound associated with it. So in this case right here, the only thing we have to do is we have to add up the mass numbers at the beginning and at the end. So 238 is the mass number, which means now this is the mass number of helium. It's got to add a 234. Because 234 plus 4 is 238. This is a law of conservation of mass. The same with the atomic numbers. This 90 here. Alpha particle is 2. So 2 plus, I'm going to say 90. You get your periodic table. You go to 90 at the atomic number. That's going to be 90. That's going to be thorium. So this is the atomic number. So get your periodic tables, look at 90, that's going to match up with thorium. So thorium is going to be emitted. Let's look at this one. In this case, Mn, that's actually manganese, 56, again, that's the mass number, undergoes beta decay. So that 56, remember, that's the mass number. And this right here is manganese. It undergoes beta decay, so it's going to give off a beta particle. Couple of things. So this is magnesium 56. We look up its atomic number, so just locate manganese on the periodic table. Its atomic number is 25. And again, make sure you have a periodic table. When you look at this video, look it up, locate that 25. It emits a beta, it undergoes beta decay, so it's going to emit a beta particle, which is 0 - 1 e. And we're trying to figure out what other element gets produced from that. This is 0. This is going to be 56. So the mass number of that new element has to be 56. So 56 plus 0 is 56. Again, the top numbers line up, bottom numbers line up. Simple as that. This is -1. Just be careful. So this atomic number has to be 26. So 26 plus -1 is going to give you a 25. So again, remember, that's -1. It's not +1. It's -1. With that, if you do that, 26 is actually iron. So if you get your periodic table, look up atomic number 26, which is going to be that top number in the periodic table. That's going to be iron. And so that's your final answer with that. Let's look at this last one. We'll say molybdenum-98 absorb a neutron. So if things absorb neutrons or gets hit by neutrons, you can actually become radioactive. So molybdenum is going to be MO. It's 98. Its atomic number, you look up, and I think actually its atomic number is going to be 42. Couple of things. When you have a neutron there, I didn't give you that symbol there for that. A neutron has an atomic mass number of 1. So again, remember, symbol is going to be N. So again, that top number is a mass number, which is the number of protons and neutrons. Just one neutron is going to be 1. And it doesn't have a charge, doesn't have an atomic number, so that's going to be 0. So I'll give you this on a quiz or exam. So 1, 0, N. So it's going to absorb a neutron. So basically, the one thing we're going to do is 98 plus 1, that's going to be 99. 42 plus 0 is 42. So, again, it's going to be molybdenum, but now molybdenum is being more radioactive. So again, to make something radioactive, a lot of times they hit it with a particle accelerator, which is basically neutrons. It increases the mass number, but the atomic number is going to be the same. So again, now I have molybdenum 99.